A, B, or C. A similar term in our algebra, in the example, like such a term defines a set of sets such that each set contains the element A and then contains element B or element C, and then followed by other elements which are not A, B, or C. So as we can see, the selective operators in regular expressions is similar to the operator square cup in the algebra. So it means like choosing one element out of two. And the concatenation operator in the regular expressions is similar to the old-time operators in our algebra. And both regular expression and our algebra allows the expression of negation, and both regular expression and our algebra has the closure operators. However, there are several differences between the two. One difference is in strings. We can have duplicate elements. For example, you can have the character A may appear several times in a string. However, in a set, an element can appear only once. Another difference is that in string, a string is order dependent. So the string AB is different from the string BA. However, in sets, they are treated as the same. And there are limitations of the expressive power of our algebra. So although it is very expressive, there are some set of sets it cannot express. So as we know, regular expression cannot express a set of strings such that the string contains equal number of A and equal number of B. So similarly, our algebra cannot express a policy which requires equal number of members of row R1, and as members of row R2. The reason is that we restrict the use of the unary operators closure to precisely capture the security policy we can express. If we allow the application of the closure operator to any terms rather than just terms that does not use O dot and O times, then the algebra can express such a situation. So when the algebra is not used to specify security policy, then I think it's possible to allow the closure operator to apply to any terms in the algebra. However, even with such an extension, the algebra cannot express a policy that requires the number of users who are member of row R1 is the same as the square of the number of users who are row R2. So the conclusion is we have introduced an algebra for specifying high-level security policies, and we have studied the algebraic properties and two computational problems associated with the algebra, which are the term satisfiability problem and the user set term satisfaction problem. We have also explored the relationship between the algebra and regular expressions. in the future, we would like to study how to enforce the policies expressed in the algebra. And policies in the algebra can be enforced either statically or dynamically. And we would like to look into both approach. And furthermore, we would like to study the term implication problem. The term implication problem asks whether a set of user, given any configuration and any set of user, if this set of users satisfy the first term, then it implies that this set of user also satisfied the second term. And also we would like to study the expressive power of the algebra when it is used to specify set of sets rather than specifying high-level security policies. And finally, since the algebra can be used to define set of sets, we think the algebra could be used in area other than specifying security policies. So we would like to take a look at explore other potential use of the algebra. So that's all of the talk.
For example, for your typical policies, so what is the typical size of the policy you specify?
What's the size of the policy?
Yeah, the length of the expression.
Normally, you mean how long? Whether we need a very large term, very complicated term to express a policy?
Right.
Normally, we think that the term used to express a policy should be small. It's not, in practice, we don't expect a policy to be very complicated. So we don't know exactly how long the term should be, but normally it's not going to be very large. Yes?
What is like the major practical application of this? So I mean, from the standpoint of maybe programmatically or just like a practical technological implementation of this.
What's the practical? So you mean how to use this algebra in practice?
Well, yeah. I mean, if it's used in practice, I mean, not just so that we can specify the policy. I mean, how would it be used programmatically, or how would it be used at a level where it would be implemented somewhere, right? Not just like from a standpoint of discussion.
So you mean how to enforce this policy, like have a program?
Yeah, I mean, anything to that nature.
So it's like how to. Let me see. So I think your problem is kind of related to how to enforce the. So it's like given a term. So are you asking how to determine whether a set of users satisfy a term, or?
I mean, it's okay. Don't do that. I mean, I was just wondering what would be possibly the practical application of this, or how would it be applied practically?
So in practice.